All right, class, today's lesson is on transformation. And today we'll look at um, the bell ringer or the warm problems. We're given three graphs, three functions, and we're asked to match each function to each graph. All right, so let's look at the first function. In fact, if you want to pause the video and see which function match the graph, go ahead and do that, and then you can come back and check your answer. All right. Now, let's look at the first function. There are two ways you can look at this. One, you can find the vertex of the function, right, and then see which graph has that vertex. So let's look at A. The vertex for A is 5, 3. That is the vertex. Remember, you change the sign of the number inside of parentheses. Now, which graph has a vertex of 5, 3? Well, you can see that is the second graph. So this is the function A. Okay. Let's look at B now. The vertex for B is, again, we're going to change the sign of the number inside of parentheses. So that's going to be -2, -7. Which graph has a vertex of -2, -7? And as you can see, this is it. So this one is function B. And then C, the vertex of C is 0, 4. And which graph has a vertex of 0, 4? That's the first graph. All right, so this is C. So that's one way of looking at it. Another way is if you look at the expression, right, x minus 5, that tells you the graph shifted 5 units to the right. 5 units to the right, and it went up 3 units. So which graph went 5 to the right and up 3? Well, that's A, right? It went 5 to the right and went up 3 units. So that's why that one is A. And for B, +2 means the graph shifted 2 units to the left and went down 7. Okay? And so that's this graph right here. And on C now, the graph does not shift left or right. It does not, right? It only went up 4 units on the y-axis. So that's why that is A. All right. Let's look at the domain and range. The domain is going to be all real numbers, right? And for what we're doing right now for parabolas, there are no restrictions on the parabolas, all right? And so the domain is going to be all real numbers. Now for the range, a range of y values. So let's look at this first graph here. If you notice, the lowest y value on this graph is 4. And so there are no y values for the graph below 4. There are no y values for the graph below 4. They are all above 4. So the range is going to be y is greater than or equal to 4. For B, okay, for the second graph, the lowest y value, right, for the graph is 3. And again, there are no y values below 3 for the graph. No, they're all above 3. So the graph, the range for this is y is greater than or equal to 3. And again, the domain is all real numbers. And for this one, again, you can pause it if you want to pause the video and try, see if you can figure out the range and domain for this one. So remember, the domain is, for this, is going to be all real numbers because there are no restrictions on the graph. The graph keeps on going up. And the range, let's see, the lowest y value for this graph is -7. And all the y values are above -7. So that's going to be y is greater than or equal to -7. All right? Okay, so that's the warm-up. Now let's go into today's lesson. Here you have 3 graphs, and it asks you, what do you notice about the vertex of all 3 graphs? Well, they all share the same vertex, right? They all share the same vertex. All right. And can you determine the vertex? Well, let's see. The vertex here is 2, 1. So this is 2. I go across 2, and halfway is 1 right there. So that's 2, 1. 2, 1 is the vertex. Describe what is different about the graphs. What is different is that I would say h of x, right, is wider than g of x and f of x. Okay. So if you look at it, as you go from the green graph to the blue to the red graph, it gets narrower, and to the blue graph, which is f of x, it gets narrower. Okay. So that's one way of looking at it. Okay. Let's see what the next slide is. Okay. Okay, so we're going to graph these 3 functions. We're going to use Desmos to graph them because I want to make sure KVA understands you. Some of them don't have the yellow calculator, so I want them to use Desmos to look at this. So we're going to graph these 3 function Desmos and see which one is the widest. So let's look at Desmos. Okay, went back too far. Let's look at Desmos. Okay, do I have the right? Here we go, Desmos. Okay, so we're going to plot. We're going to plot those 3 functions, and if I can get my notes correct, those 3 functions are. Here we go. Okay, I couldn't find my note sheet. The first one is we're going to use f of x is equal to x squared. I'm just going to use this y, okay? Put y is equal to x squared. That's the first one. And then the second one is g of x is equal to 3x squared. Again, I'm going to use y is equal to 3x squared, 3x squared. Okay, and then the next graph is going to be, okay, 1/2 x squared. So let's use y is equal to 1/2 x squared. Okay. So let's look at, you have 3 graphs there, and it wants to know which graph is the widest. Well, the widest one is the red graph, which is the 1/2 x squared. Okay, so that is the widest graph. If you notice now, I want you to notice now, the widest one is the one with a fraction. And if you look at the purple graph, x squared, right? The coefficient of x squared is 1. And then let's look at the black graph, it is 3. So as we go from 1 to 3, all right, you see the graph gets narrower, or we call it stretch. All right, so let's go back to this. So which is the widest one? That is the, this one is the widest one. All right. Okay, let's see what's next. Okay, so make a prediction now. So you're given 2 function now, right? 2 function, and you're asked to make a prediction. Which one do you think is the wider one? So based upon what we did in Desmos, right? Which one do you think is going to be the wider one? If you guess g of x, you're correct, right? Because the fraction is going to make it, because the coefficient is less than 1. It's a fraction. It's going to be wider. So g of x is going to be wider. All right. Let's see. Chris, is asked to write these three functions, right, in order from the narrowest to the widest. And did he get them correctly? Well, let's see. We have 3 and 5. So which one is going to be the narrower of those two functions? Well, because h of x has the larger coefficient, which is 5, that's going to be narrower. So this go first. So you should have h of x first. Okay, because that has the bigger coefficient than g of x. All right, and then f of x. So this is the widest one, then g of x and h of x. Okay. Now let's look at how do you think this, what do you think happens if a is negative? Well, we have two graphs. G of x is equal to 3x squared and f of x is equal to negative 3x squared. The only difference here is that the coefficient is negative for one of them. So one graph is a reflection of the other. So if you graph this in, and you can try this in Desmos, if you graph this, all right, it's going to look something like this. 3 of x squared is going to be something like this. And I'm just sketching it, okay? Not quite. And then because then f of x now, because it's at negative 3, it's going to be a reflection of, g of x. It could look like this. Okay? So this is f of x. And this is g of x. Okay? So when the coefficient is negative, the graph opens downward, and when it's positive, it opens upward. All right, let's see what we have here. Now, this, I want you guys to get really familiar with this equation, the vertex form of the quadratic equation. This will help you out tremendously in answering questions pertaining to graphs or quadratic equation. Now, let's look at A. Now, A is the coefficient, and we said before, if A is negative, right, the graph is going to open downward. So let's look at an example for an equation. Okay, let's go with blue. Blue goes well with red, or maybe black. Let's go black. Suppose we have y is equal to 2 times, let's say, x minus plus 4 minus 6. Okay. Now in this case, my a is 2. And because it's positive now, because my 2 is positive, the graph is going to open up this way. All right. And again, this is a rough sketch, guys. Don't hold me to, okay, don't hold me to this. I'm just going to show you that the graph opens up this way. All right. And so that's A right there. If A was negative, right, then it would open downwards. Now, when A is positive, right, again, the graph opens upward. What's going to happen is you're going to have a minimum point. See that? And conversely, if A was negative and the graph opens downward, you get a maximum point. All right, so that's one of the key things I want you guys to remember that. Now, here we're going to talk about stretch. Remember how when we graphed those three equations and one was wider? Well, the one that was widest, right, it had a fraction. So whenever A is a fraction, if it's between 0 and 1, right, you're going to have what we call a vertical stretch or skinnier. So let me write here. So if A is less than 1, is between 0 and 1, you're going to have a wide graph. Okay. And if A is greater than 1, then you're going to have a a skinnier graph, or a narrow graph is going to be called a vertical stretch. So these are two things I want you to remember. So if it's a fraction, you're going to have a wide graph, and if it's greater than 1, you're going to have a skinny graph. All right. So that's A right there. And then this expression right here, the x minus h, tells you if the graph goes to the right. Right? If this in this case right is a positive 4, therefore the graph got shifted to the left. If it's a negative, oh, that's the wrong color. If it's a negative, then you know the graph got shifted to the right. So make sure you understand that. And then K is the -6 right here. It tells you if the graph went up or down. Right? And -6 means the graph got shifted down, and a +6 means the graph goes up. So you've got to know this equation in and out and all the different features of it. All right, so here we're going to look at some examples right here. We're going to match up the function with the graph. I encourage you to pause the video, attempt this on your own, and come back and check your answers, all right? So here we go. We have y equals x plus 5 plus 1. So I know this graph shifted 5 units to the left and it went up 1. So that's one way of looking at it. Or I can say the vertex is, it went 5 to the left and up 1, okay? Or I can say the vertex is -5, comma 1, and we know it's positive right here, right? Positive, so it's going to open upward. So let's see which graph has a vertex of -5, comma 1 and open upwards. Okay, -5, comma 1, which, okay, let's see. Let's look at this one. I'm sorry, -5, comma 1, that will be A, right? The vertex is -5, comma 1, and it opens upwards. Or you can say the graph shifted 5 units to the left and went up 1. So this is A right there. Let's look at number 2. Again, we can say the vertex is 5, comma 1. Okay. And so it should be the opposite of this one. Let's see, 5, comma 1. So here we go, right? It shifted 5 units to the right and up 1. So that's D. And the vertex is 5, comma 1. So again, so that will be D. Now let's look at these two functions right here, number 1 and number 3. You notice, right? They're the same function except A is negative here and this one is positive. So what does that tell you? All right, one is going to reflect, one is going to open downwards. So let's look at number 3. The vertex is -5, comma 1, but opens downward. See right here, that's C. So if you notice now, A and C, they're pretty much the same graph, just that one opens upward and one opens downward. So C is a reflection of A. Okay. And look at number 4. Again, number 4 is a reflection of D, right? And D is, so which one looks like D and reflects? All right, so that would be this one, B. And let's see. The vertex for D is, for number 4 is 5, comma 1. Well, because this is negative, it's going to open downwards. 5, comma 1, that's the vertex that's right here, opens downward. And if you notice that, again, this is the opposite. It reflects from D. Okay, and let's number 5. Number 5 now, key things to notice now. Number 5, the coefficient A is greater than 1. So what does that tell you? You're going to have a skinny graph, a narrow graph, right? Or a vertical stretch. So which one is that going to be? Well, that's E. And 1/5 is a fraction between 0 and 1, so that's gonna give you what we call a compressed or a wider graph, and that's F. All right, guys. So make sure this is very good. Make sure you understand this, how this works. Okay, let's move on. Now, these are some STAR questions. You sometimes STAR questions, they're worded kind of, weird. And so I want to go over these STAR questions so you understand them. So let's look at this one. It says that the graph of f of x is equal to x squared. That's this graph right here. That's the parent graph. And it got transformed to another graph, which is 7x squared. So look at those choices, F through J, and see which one is the correct answer. Now, if you get stuck and you're on a test or or a quiz, you can use a calculator and graph both functions, but that's going to take some time. Let's see which one it is not. Well, the question didn't say that. Well, it's not going to be H and J because H and J talks about below and above F. Nowhere the question talks about that. 7 just means that the graph is skinnier. You got a vertical stretch. So it's not going to be H or J. So the correct answer is F. All right. G is narrower or vertical stretch or skinnier. Okay, next one. Again, you're given two functions, Q and W, and the graph on the same plane, same coordinate. Now, here's the key. The vertex of Q, right? The vertex of Q is 18 units below the vertex of W. Okay, go ahead and pause the video again and see if you can figure out the answer for this one. Now, it is not going to be 18. It's not going to be A or C because A and C are talking about a vertical stretch, a skinnier graph. Nowhere it talks about that in the question. So it's not going to be those two. Plus 18 means that Q is above W. It did not say Q is above W, so it has to be D, right? Next one. The graph of f of x is x squared. Again, that's the parent graph, and it's transformed into h of x is equal to 2f of x. Again, if you notice this 2 right here, right? This 2 just means that the graph got stretched. So which one got stretched from the original graph? Well, H, if you look at it, it's going to be J, all right? J is skinnier than F. All right. Next one. Again, go ahead and pause it. What is the vertex of this one? Go ahead and pause the video and see if you can figure this one out. The vertex is, again, in this case, it's the lowest point on the graph right here. And that is 1, -2. And again, this is going to be a minimum right there, okay? And we can also look at this. The axis of symmetry is going to be x equals 1. It has the same value as the x coordinate on the vertex. All right, let's move on. This one, you're given a graph, and it was transformed. Again, the parent function f. Remember, the parent function, right, looks something like this. Right to the earth. That's the parent function right there, okay? And that was transformed to create a graph of f of x plus 2 minus 5. So what does it tell you? Well, the new graph got shifted 2 units to the left and went down 5 units. So which graph is that? 2 units to the left and down 5. Okay, 2 units to the left. Well, the only answer is H. all right? Or you can look at it this way. The vertex of the new function is -2, comma, -5, all right? And of course, the function is positive, so it opens upward, and that's it right there. All right, let's see what's next. Again, the graph of f(x), this is a parent function, was transformed to create a new graph of f of x minus 9. What does that tell you? Minus 9, right? That's the k value is negative, so what happens? Okay, go ahead and pause the video and see which one you think is the correct one. Okay, now if you say D, that is correct, right? The graph, the y-intercept of graph is 9 units below, all right? You got to shift it down, okay? And I think this is the last one. Again, the parent function f of x is equal to x squared was transformed to create the new function g of x, which is x minus 7.5 squared, which will be described the transformation. All right, go ahead and pause video and see if you can figure this one out. All right, let's see now. Remember, x minus 7.5 squared, right? There's a negative sign here. That means the graph got shifted to the right. So which one is it going to be? It's got F, right? It's a horizontal shift to the right, 7.5 units. All right, and I think that's the last one here. Yeah. All right, guys. Again, the key to this, you've got to remember this this equation right here. Let's see, where's that? Okay, here we go. Make sure you understand this equation and the different parts of it, how it works, and that will help you tremendously. All right.